Hello, everyone. Welcome to our webinar today on single skin metal siding, performance and design considerations. It's presented by AEP Span. I'm Paul Deffenbaugh. I'm the editorial director at Metal Architecture magazine, and we're glad you've joined us. Today's webinar is part of our series of webinars at Metal Architecture, and our speaker is Tyler Murray. Before he kicks off with some great information, I wanted to touch on a couple of bases here. The webinar is going to last an hour, and Tyler's going to take questions at the end of each section. There are 4 sections, and he will do so also at the end of the webinar. Submit your questions on the panel on your screen, and I'll raise them with Tyler when we have a pause. A lot of you will want to know about how the CEUs and certificates are going to be handled. You don't need to do anything. It's all handled automatically, but please allow us 7 business days to process all of that. Now let me turn things over to Tyler. Tyler Murray is the technical service representative for AEP Span. He oversees the weather tightness warranty program in the greater Pacific Northwest. He's been in the construction industry for 20 years with a concentration in roofing installation and inspection. Tyler's got a lot of certifications in his field, as well as a deep understanding of the products associated with the roofing industry, and he holds the OSHA 510 outreach training card. Tyler's experience in the industry has included roles such as a journey level roofer, estimator, project manager, and prior to working with AEP Span, he worked as a lead tech representative in the Northwest for a worldwide roofing products manufacturer. He's responsible for job site inspection, final roof inspections, warranty claim investigations, and product training for installers, as well as technical training for other technical representatives throughout the United States. Tyler's got a wealth of information, and you're going to want to ask him questions, so please do so. Tyler, take us away.
Thanks a lot, Paul. Hello, everybody. Welcome back if you've been through this presentation before, and if not, welcome. We'll just get right into it here. Like Paul said, this is the single skin metal siding performance and installation considerations. Of course, I'm going to have some trouble forwarding my page. That's always a great way to start. There we go. Here's the AIA information. As Paul had said, you guys don't really need to do anything with that. They take care of all of it. But here's a little blurb on the provider number and the course numbers if you guys wanted to write that down. Single skin metal wall siding is a great example of the continued advancement of building products in the architectural market. It's driven by more sophisticated designs and has a greater emphasis on sustainable building practices. Emerging trends will shape the architectural market as people become aware of the environment around them, and single skin panels are on the forefront of this trend. This course will explore the different types of single skin metal siding, the specification details, and also the performance and design considerations. At the end of this course, hopefully you will understand material inputs and performance attributes for architectural single skin metal siding. We'll be learning about the environmental impact and sustainability of single skin metal siding. We'll begin to understand the types and the specification considerations, and then again we'll learn the design and installation considerations that will facilitate a successful single skin metal siding solution for your buildings. So in learning objective number 1, it has a breakout of how the actual steel is comprised with its with the paint systems and the cool top coat. Excuse me for just a second, sorry about that. The base metal comes in a variety of ranges and thicknesses, and it comes in a couple different materials. Not only do we talk about steel in this presentation, but we also talk about aluminum as well. Single skin metal siding is 100% recyclable. On the right-hand side, you'll see a little drawing of how the actual base steel or aluminum is made up, and during the coating process. The first coat, of course, over top of the base steel or aluminum is the aluminum and zinc coating. And then as far as part of the paint process is concerned, it goes through a pre-treatment, a primer coat, and then the cool top color. Metallic coatings provide corrosion protection. The aluminum zinc coating is comprised of 55% aluminum and 45% zinc. Galvalume and Zincalume, which are both registered trademark names. The aluminum component provides barrier protection and it's fairly inert and does not corrode. The zinc, which is 45%, provides the sacrificial characteristic that protects the material edges and cuts. This coating is applied to metal panels in 22 gauge, 24, 26, and 29. And the galvanized coating is 100% zinc, and can be applied to materials as thick as 18 gauge all the way up to 29 gauge. Aluminum does not require corrosion protection coating. So unlike steel, aluminum is not coated with a different metal to protect it from the elements. The other coatings that go on during this process are the pre-treatment, the primer coat, the cool top color, and then the backer coat, of course, which is what would be shown on the underside of the metal or on the back, if you will. Galvalume or Zincalume with a clear top coating provides a beautiful finish. It offers that bare steel aesthetic design while resisting scuff marks and fingerprints during installation. And then it does have some energy efficient attributes. So the base steel or aluminum, again, as far as the bare Galvalume or Zincalume is concerned, it's the steel and then the zinc coating and then a top resin coating, which is clear. And with this particular product, the resin coating is on both sides, so you have the same look on either side of the metal. So these are the good, better, best sections as far as the material inputs and performance attributes of the coatings. The polyester would be good. The SMP paint or the silicone modified polyester is better, and the fluorocarbon, which is Kynar Hylar, is best. And that's what I see most often in the field, is that PVDF or that Kynar coated sheet metal. The cool top coat, as far as polyester paint is concerned, the distinguishing features of that is that it's cost effective. It has a good flexibility and hardness, and it comes in a wide range of colors. The typical applications would be that paint is typically used as a backer coat for metal siding panels. It's a commodity or exterior low-end interior applications. And then the gutters, downspouts, the agricultural metals, light commercial and residential trim. The SMP paint systems has a better exterior weatherability. It has a wide range of cool colors with energy efficient attributes. It's a lower cost than PVDF coatings, and it's typically provided with a film integrity chalk and fade warranty. Typically, it's applied on commercial and residential siding and roof applications, and most of the time they use it on a lighter gauge profile. Now down to the PVDF paint systems. The PVDF is a premium system used on high-end architectural projects or in an aggressive environment. Some of the distinguishing features that it has: outstanding resistance to ultraviolet radiation, It has an exceptional color retention, excellent chalk and fade, chemical resistance. Again, it also has a wide variety of cool colors with energy efficient attributes. Typically speaking, it has the longest film integrity. And then typically often, excuse me, it's a specified requirement on the job. Some of the applications include educational buildings, public, government, healthcare, and commercial projects, and then environments where superior weatherability is required. So it's basically the top dog as far as the paint systems are concerned for single skin metal siding. So people do also offer a PVDF marine paint system, and it basically gets modified or altered in a corrosive environment situation, including industrial installations and marine locations. This is achieved by using a thick coat primer and or a clear coat to provide extra corrosion protection. And then depending on environmental specifics, warranties may be available for this paint system. So the marine paint, again, it's a little bit beefier, and how they achieve that is they thicken the primer coat and they add a clear coat to the top of the system. So the cool colors are known for their reflectivity. The same coatings with solar reflective attributes for cool metal roofs are also applied to single skin siding panels. The solar radiation reaches the Earth's surface in 3 distinct wavelengths: UV 5%, infrared, and visible, which makes up 44%. IR radiation is responsible for the generation of heat on surfaces. The cool pigments have been altered with special IR reflective pigments that stay cooler than traditional pigments. Cool sidings contribute to cooling cities, conserving energy, and saving money. I'm going to go into the LRV values a little bit. So light reflectance is the visible light reflected by a surface and is measured for the amount of visible and usable light that is reflected from a surface when illuminated by a light source. LRV is expressed as a percentage from 0 to 100. The higher the number, the more visible light that is reflected. The manufacturer should be able to provide the LRV for a specific color. So in the shown below are some of the different colors: the forest greens 1 and 2, dark bronze 1 and 2, parchment 1 and 2, black, and you can see the differences in the LRV values with the 60% gloss or 85% sheen. So there's a lot of different things that go into that consideration, and as far as either raising or lowering the LRV values. That's the end of that objective.
And we've got a number of questions if you got a moment.
Okay.
One of them is you list, I think, 3 paint systems in this presentation. Are they all typical for metal applications, the polyester, the SMP, and the PVDF? And do all of them have cool ratings?
Yes. The first part of your question, the answer to that is yes. You typically see most of those in the real world. They get applied every day. Like I said during the presentation, the PVDF is the one that I see the most often. And then all 3 of them, yes, are formulated with the cool pigments, and then they should have published reflectivity and emissivity values from reputable manufacturers. So what I'm saying there is all 3 of them are cool, yes, and you should be able to figure out how cool and what their values are by going directly to the manufacturer.
Thanks. And one other question, and I'll let you go on, and we can take questions at the end of the webinar as well. This question is, how long does it take for the top coat to start to fade, and are there colors that fade quicker than other colors?
These days, the answer to that question is no. I don't see any chalking or fading in the field at all, as compared to, let's say, 20 years ago, when that was kind of a huge issue. 20 years ago, you could go onto a colored metal roof, didn't really matter which color it was, and run your hand on that, and you would come back with chalky film on your fingertips of your gloves. In my years of experience with steel roofing and siding, I have never been to a job that had a chalk and fade warranty claim. So basically what I'm saying is these paints don't do that anymore.
Great, thanks. Let's keep pushing on here, and a reminder that we're going to take more questions going later. Thank you.
Okay, moving on. So the environmental impact for single skin metal siding, the Lawrence Berkeley National Lab, LBNL, explored cool siding benefits, technology, and infrastructure in a recent project sponsored by the California Energy Commission's Electric Program Investment Charge. The research overview was from 2015 to 2018. They evaluated the annual energy cost and emission savings in all California climates and U.S. climate zones 1 through 4. The energy simulation program to model the consumption for a range of buildings, residential, multifamily, various sizes of office buildings, standalone buildings, strip malls, restaurants, and a large hotel. The key takeaway from the research were that cool sidings save energy, money, and carbon dioxide in warm climates. They also help mitigate the urban heat island. They tend to stay clean compared to roofs, and they're reflective. And metal siding products are available today at no extra cost. The Berkeley Lab seeks to expand and enhance current cool siding provisions in the U.S. In the U.S. codes and standards and green building programs. The advanced cool sidings are currently found in U.S. codes and standards and green building programs. They're developing new cool siding measures in the codes and standards. The key is to establish a cool siding product rating system. Developing credible methods to evaluate and label products, establishing a cool siding product rating system, modeling it on or expanding in the existing programs. The CRRC is proposing to create a rating program for exterior siding products. So the single skin metal siding products can contribute to green designs and the certification programs that are associated with that, such as LEED V4.1, Green Globe, the Living Building Challenge, and then the Collaborative High Performance Schools, which is state of California only, I believe. Here's a breakdown of some of the LEED 4.1, the primary contributions as opposed to metal roof and siding. I'm not going to read through this whole thing, but basically, this kind of just breaks down the four categories as far as a sustainable site is concerned, energy, atmosphere, and then the materials and resources that were used, and then the indoor environmental quality. The Living Building Challenge is one that most metal manufacturers try to adhere to. The building products fit into the materials petal of the Living Building Challenge. Disclosure of products 100% ingredients to 100 parts per million, specifically materials and chemicals on the red list. Today, metal siding panels are able to meet the criteria for the LBC red list free. Metal siding panels coated in zinc aluminum, also referred to as galvalume substrate with a clear protective resin coating, meet the LBC red list free criteria. They can be ordered as a standard offer and at no extra cost. It offers a natural steel aesthetic design, and it's available in multiple profiles. We kind of talked about this in the coating section in the beginning of the program here. This is the one it's just bare. It just looks like bare zinc aluminum, and it's got a resin coating over the top. So that is one of the ones that meets that Living Building Challenge red list free criteria. Siding panels in a painted offer meet the LBC red list free criteria. Also, they're typically a special order with minimum order requirements and at a higher cost. The challenges with this is hesitation by coating manufacturers to provide proprietary information on paint formulas. So in order to qualify for the Living Building Challenge, the red list free criteria, the paint manufacturers need to give up their recipes. And so they're hesitant for that. Standard corrosion resistant primers contain low levels of chrome, which makes it hard to meet that LBC criteria. The factory applied paints are often contain a curing chemical that, while on the red list, is reacted and eliminated during the curing process. Despite the presence of a few red list substances, pre-painted metal is inherently safe and does not pose a risk. There have been performance trade-offs, which was significant until recently, and then progress is being made on trying to meet some of these criteria. That's the end of objective 2.
Thanks, Tyler. A couple of questions here, and somebody's curious about the comparison of the current LEED 4.1 model to previous LEED versions. Can metal siding contribute more points now than were eligible in previous LEED versions?
Yeah, previous LEED requirements only allowed points for recycled content, which was 2 points, I believe. The heat island was 1 point only. A regional material, if that material is sourced within 500 miles of the project. So the current LEED V4.1 has more categories for the LEED point accumulation. New categories would include energy and atmosphere, and you can get from 1 to 6 points for that. Then materials and resources is up to 14 points now, and that's based on category compliance. And then the indoor environmental quality, which is anywhere from 1 to 3 points. So the walls are still not available or eligible for heat island credits. However, I feel that that once the CRRC established a rating system, then the wall systems will start to get included in that.
Thanks, Tyler. I want to go back a little bit real quick. You described PVDF as being good in an aggressive environment. I think that was the term you used. And I wanted to clarify what an aggressive environment is, and then also maybe tie that into this question. Are there differences for PVDF and marine paint warranties?
So an aggressive environment would be like a saltwater environment. Most manufacturers' general rule of thumb is that if you have a building and it's within 1,000 feet of a saltwater source, then they would, recommend that you go with that marine coating finish. But it also can be in an industrial environment too, like a paper mill or something to that effect, where there's some type of, and just I don't want to say pollution, but like a corrosive environment due to where it's at exactly in that paper mill or what have you.
I think I kind of bollocksed up that question before. Let me kind of reiterate it, re-say it. In that marine environment using PVDF, are there changes to the warranties? Is probably an easier way to say
Oh, I got you. Well, that was the second part of the question. So that's kind of a tough question. It's gonna really depend on manufacturers. I can speak for our company, and it also sort of depends as far as what you get for a warranty. They look at it in a case-by-case basis based on geographical location and things of that nature, and how aggressive the environment is. So yes, there's a difference in warranties from marine coatings as opposed to not.
Okay, great. Thank you, Tyler. Let's keep going on, and we'll take questions, more questions later.
Okay. Objective 3. So we're going to go over some of the attachment methods. Metal siding is identified and categorized by its attachment. They have two types. One is the exposed fastener type, and the other is the concealed fastener type. The exposed fastener siding relies on a visible fastening device to secure the material to the structure. The common gauges tend to use a thicker material. 29 gauge through 22 gauge are industry standard, and the gauge of the aluminum will be driven by the profile. So it depends on which panel you're using. Here's some of the exposed fastener profiles. I'm sure a lot of these look familiar to a lot of people. There's pretty common profiles there. Some photos of a couple stores that have exposed fastener profiles. And with the exposed fastener panels from afar, you can't really tell that there's, unless you know already, but you can't really tell that there's fasteners that are holding that metal to the wall. Couple more shots of some exposed fasten profiles. So some of the concealed fasten profiles, they provide a clean line by eliminating the need for exposed fasteners. They're often chosen over exposed fastener panels where weather tightness is a concern. Direct attachment or clip attachment to the siding of the structure, typically with steel, 24 gauge and 22 gauge are industry standard, and then aluminum, again, the gauge will be driven by the profile of the panel. Concealed fastened siding has no visible attachment points. The picture on the right-hand side there is a pretty good one. That's just a flat metal wall panel attached and installed on a horizontal. There's a couple more. These two pictures show the difference between a horizontal and a vertical application as far as the concealed fasten systems are concerned. So thermal movement or expansion and contraction is something that the environmental factors drive primarily for temperature fluctuation, causes that panel to expand and contract. Steel panels, 1/8 of an inch of expansion and contraction per 10-foot panel length is the golden rule. The aluminum panels, the thermal movement is almost twice the rate of metal, making it upwards to 1/4 per 10 of panel length. Most concealed fastener assemblies allow for thermal expansion through the use of single piece clips that slide within the panel seam. So on a concealed fasten profile, that panel will be expanding and contracting and sliding along the attachment clips. In an exposed fastener situation, the assemblies, they don't accommodate for thermal movement, obviously, because it's fastened so often. The fastener mounting hole may stretch or tear over time. The exposed fastener systems are all about fit for purpose. It provides a classic look with a variety of profile configurations. It's also offered with an attractive array of modern finishes and textures. That's easier to install, obviously, and the cost make them an attractive, low-cost solution. And then they're pretty easy to repair or replace. With proper sealant placement, the exposed fasten systems can provide adequate air and water infiltration control and may have been tested and approved through the ASTM method. Here's a model of the lap configuration. It's a traditional side lap shown here. One panel rests over the other. This is most commonly found in the exposed fastener siding panels. And then field applied lap sealant is required to keep the side laps watertight. And that's shown in red there. This is the integral seam lap concealed fasten system. It utilizes a male and female lap engagement. The panel attachment is achieved by directly fastening through a nailer strip on the female leg. The male leg is then interlocked, thus concealing the attachment points. Some integral seam panels offer clip attachment as well. These are typically offered with factory sealant in the female leg, or it can be field applied. Manufacturers also offer what's called a hook seam lap. It utilizes two reverse rolled hems that positively engage each other. The panel attachment is achieved by direct fastening through a nailer strip on the mounting flange of the panel or with a clip. The other side of the panel has a leg or a hook that is then interlocked, which conceals the attachment points. Some integral seam panels offer clip attachment as well and are available with factory or field applied sealant. That means to say some hook seams are available with clips. So the lap configurations, each panel offers the designer a choice depending on the project's structural and aesthetic needs. The traditional side lap and hook seam systems generally have a substantially higher structural performance when used with clips. They offer better weather tightness than exposed fastener panels due to their concealed attachment and may have been tested through the ASTM method. The integral and hook seam panels are generally preferred for the most visually demanding architectural applications and are fairly easy to install. One-piece clips used with the hook seam panels offer a simple, are often simple in design and provide ultimate thermal movement. So that was the end of objective 3 there.
Thanks, Tyler. I'm going to blast a few questions at you here. There are a number of, somebody noticed that in a number of these photos, the standing seam roof panels are being used in wall applications. Is that accurate?
It is, yeah. I see it a lot in the field. This presentation is centered specifically on wall panels. Standing seam roof panels are gaining popularity in the wall market segment. They offer concealed attachment, which we just spoke about, and super clean vertical lines. Some of the more reputable manufacturers have details for installing the standing seam panels, roof panels on a wall application.
We talked a lot about coatings and that sort of thing for panels, and somebody wants to know, are the fasteners coated as well, and how to prevent corrosion?
They are. Most manufacturers obviously don't manufacture the fastener as well, but they do. The fastener manufacturers do paint matching, and they do offer a similar paint system as what's on the steel. It's also a baked on system. I can't comment on to whether they're PVDF or not, but I believe they are. And but yeah, so similar paint system on the fasteners.
One more quick question about exposed fastener systems, and are they used in roofing?
Yeah, all the time. Happens a lot. Again, most of the time when I in the field, when I see that residential applications as far as porches and patios and things of that nature. And then in the agricultural market, I see it constantly as far as roofing panels used in, or I mean, excuse me, through fastened panels used in a roofing application.
Thanks. We've got a number of slides to go through here on our final learning objectives, so I'm going to hold off on questions until the end. So thanks, Tyler.
Thanks, Paul. So this section covers the vertical and horizontal applications. Spoke about that a little bit. We looked at some of the photos earlier. These are two great photos. The one on the left obviously is a vertical installation, and then the one on the right actually has both vertical and horizontal in the same setting. The vertical application offers the installer the flexibility in installation by allowing the panels to be laid left to right or right to left. The horizontal panels, as far as the integral seam panels, are intended to be installed from the top of an elevation down due to the seam configuration. If integral seam panels are installed from the bottom up, the female leg can trap the runoff from rain, which can compromise the weather tightness over time. So this is something that's been a bit of a learning curve with the applicators. It kind of just goes against everything that they've learned as far as installation of siding or any type of product actually. To go from the top down is a little bit backwards. So, but these panels perform, they perform way better. The other, from the top down, I have seen them installed from the bottom up, and it's a successful installation and it doesn't leak. But water does get trapped inside of that, as you can see on the left-hand side there. And I would imagine that it would make that system age faster than it needed to because of the moisture trapped in that system constantly. Horizontal application, the traditional side lap seams and hook seams are opposite of integral seams. The traditional side lap and hook seam panels are required to be installed from the bottom of an elevation up, which allow the runoff to flow over the lap. Installing a traditional side lap or hook seam panel from the top down can compromise weather tightness over time due to the exposed seams. So you can see from the breakout there on the right hand side that obviously if water, the one on the right there, if water's traveling downhill, it's just going to continue to be forced into that seam. We're going to talk a little bit about substrates. Single skin metal siding can be installed on a wide variety of substrates, including dimensional lumber, plywood, OSB, cold formed steel, such as C purlins or Z purlins, steel deck, hot rolled structural steel, and concrete or masonry. A critical component of a properly designed panel assembly is specifying the fasteners that hold the panel or panel clip to the substrate. The nominal fastener size is generally defined by the necessary panel, clip fastener, clearances, and the substrate. Fastener sizes approved for use with each panel are defined within the manufacturer's approval process in their installation guide or by contacting the panel manufacturer's representative directly. The fastener length, point, and thread type are defined by the underlying substrate type and the thickness. The fasteners should always be obtained through the panel manufacturer when possible to ensure that the appropriate fastener is being used and the overall panel assembly capacities have not been jeopardized. So most manufacturers have plenty of evaluation reports or product approval reports and research. Several key certification, the bodies that are used for the product approval reports, including IAPMO UES, which is the evaluation reports, ICCES, which is the evaluation service reports, the Intertech, which is a research report, and UL, which also is utilizes the evaluation reports. The process, how it works basically is the certification body develops the criteria. The manufacturer seeking that approval report submits all independent test data, performance calculations, and etc. as required by the criteria. Then the certification body evaluates the manufacturer's performance data against the requirements stated in the criteria. And then if approved, the certification body publishes the approval report. This is what an approval report looks like, or an evaluation report. The section properties are provided for the panel based on the gauge of the panel. So this is just for a typical through fasten panel here, and it goes through the evaluation report. Just kind of goes through what the testing looked like, what the limitations are, and then on the second page there, it talks about the yield strengths and tensile strengths and things like that, as far as what you're getting in the steel itself or the panel as a whole. Again, these reports, they talk about positive or inward loading based on panel gauge and how far they span between attachment points. And then the negative or outward loading based on the gauge, the substrate, the fastener, and the fastener spacing. Underlayment is intended to direct moisture to the outside of the building envelope or building cavity. Three basic needs in specifying underlayment for metal siding are as follows. One, to dry in the building so other work can proceed within the building. Two, to protect against the chance that moisture will penetrate the metal siding system and act as a secondary moisture barrier. And three, to allow a means of escape for backside condensation, which may occur in certain metal siding applications. This condensation must be directed out of the system. Siding underlayment is typically required to be semi-impermeable, which allows for the passage of vapor in one direction, which is from the inside out. It does not allow for the passage of vapor or condensation into the building. There is an underlayment class rating system. Class 1 has less than 1 perm rating, which is impermeable. Class 2, which is 0.1 to 1.0, which is semi-impermeable. And then class 3 is considered vapor permeable and can range from 1.0 to 10. ASTM E96 determines the perm rating for the underlayments. The appropriate underlayment, the siding vapor barrier is how we say it, is reliant upon external and internal siding assembly, cavity, and insulation. Type 2 or Type 3 vapor barrier is typically required given a vapor perm rating of up to 1.0. There are some exceptions, being coastal environments, refrigerated buildings, indoor pools, amphitheaters, or structures that use a non-typical deck or siding material such as tectum or lightweight concrete. Project building type, wall design, location, and occupancy type are some of the variables that will come into play when selecting the appropriate vapor barrier. The polyethylene or foil-faced underlayment is acceptable for external applications, but should not be used on the interior as it facilitates molding. And then climate zones need to be taken into consideration as often as they contribute toward the selection of an appropriate perm rating for an underlayment. So here's a couple base conditions of a typical siding details. I won't go through and read the entire thing, but this basically would be at a floor level. Starting from the bottom, you can see on both sides that the manufacturer is calling for a 1/4 inch gap there between the actual siding and the piece of flashing there at the bottom. That is to allow for thermal movement. On both sides, they outline the use of a butyl flashing tape, which is a sealant. I'm sure that most of you guys have heard of that if you're familiar with metal siding at all. But most of the better manufacturers will specify that you use some type of sealant in their metal wall panels. Vertical applications, it's important that the siding base trim is sloped away from the building. Edge creep occurs when the design has the edge of the panel positioned where it sits in dirt or standing water. And I don't know how well you guys can see that picture there, but those panels, because they've been sitting in the standing water that gets collected in the base flashing, and they're constantly wet, they've started to rust down there at the bottom. So ensure that the siding base trim is sloped away from the building, and that will be eliminated. It's a typical parapet cap on, it would be the steel that lays over the top of a wall. We call it a parapet flashing. Typically speaking, like it outlines at the top there, it has a 1/4 inch, so 1/4 slope, again, to slope that water away from the steel to keep it from standing on that coping. These are your typical inside and outside corner details. They're showing these metal panels are attached with a clip system. So you have the clip fastener, the panel clip itself, and then the substrate and the underlayment. And the one on the left doesn't really outline it, but you can see again, the one on the right, it talks about a continuous bead of non-skinning butyl tape or sealant. So that it's important. Here's something that we didn't really go over at all as far as this slide was concerned, is the closure strips. This one on the right hand side calls out for that outside closure strip, and it calls out for it to be sealed and secured with sealant. It's a typical detail here. Photos of, they're actually photos of the same building, inside and outside corner. A couple more. These are typical formed corners where a piece of flashing in that corner is not utilized. as opposed to this picture where there's a piece of flashing on both of those corner details to cover up the ends of those panels. On these ones, they use what's called a formed corner, and it's actually a piece of flashing itself, but it gives that clean look. So window or a door jamb, a head condition, louver head condition, pretty typical to that base flashing condition that we looked at. We do, they ask for horseshoe trim shims, excuse me, to hold some of that metal off the wall. Also with the 1/4 inch gap at the bottom, and then mastic as well, or the butyl flashing tape. So typical breakout of a jam condition, again with the clip fastener, the clip, the substrate, and the underlayment. And again, it doesn't outline it, but it does show that closure strip. Here's a sill condition. They do at the top of this condition, they call out for that wall closure, which is the piece of steel or metal that will shed the water away from the system. And then they do a trim fastener, which is typically a rivet, again with the bead of non-skinning, gun grade non-skinning butyl or tape. They use a Z metal in this instance to have something to attach to in that particular spot. And then again with the substrate, underlayment, clip fastener, and clip. It's a typical soffit detail. Pretty good picture of this soffit material here. See metal used in soffit conditions constantly in the building industry. It's a siding penetration detail. It looks to be, this is some sort of water or through wall type scupper. Typically speaking, they'll cut the hole for this penetration, and they'll put whatever they're putting through the wall, and then they'll, as it outlines in this picture, they'll just fasten some type of plate around that penetration, and then add sealant as needed. You can see some of the different siding penetration details. The one on the left, it's a pretty complicated little area there that they utilize they utilize some of the cap style penetrations. And then again, different type of material on the right side with the light. Looks pretty clean. So the typical siding end lap on the nestable panels, it looks about like that. It's just those panels nest together. You can, I don't know if you guys can see it, but on the right hand side of that picture there, you can sort of see where that lap's kind of showing up. This is a end lap on a non-nestable panel. Typically, these happen at the floor breaks, or in this instance where it's a horizontal application, you'd have a little beauty strip there that hides the ends of those panels. So this would be the difference between nestable and non-nestable. They use a splice plate in the non-nestable panels to beef up that substrate, so you have something to fasten your panels to. So in these two photos, the end lap splice plate will be what was used to help secure those panels at the splice. It's a vertical application of non-nestable panels. Like I said before, typically they'll put a little floor break there. Still gives a pretty clean line, in my opinion. That'll be it.
Hey, thank you, Tyler. And we have time for a few questions, and that's good because we got a number of questions here. Just a reminder, everybody, I just sent everybody a message that you are tomorrow going to get an email with links to download a recording of this presentation as well as be able to download the slides. But let's talk about, would you please touch again on why it's important to work with a manufacturer with an engineered evaluation report for their products?
Sure. I mean, it's not super critical, but it does help move through the plan check much faster. As I talked about, the metal wall panels are defined in the building code and are not considered an alternate or means or method, which would require an evaluation report. But by having one, all performance data of the profile is published for the section properties as well as the negative outward loading, which would be the wind uplift resistance, and the positive loading, which is the live load, such as someone walking on the roof, or something, like solar panels. So having those numbers available is, like I said before, it's not critical, but it's definitely helpful.
Great, thanks. Tyler, I'm going to combine a couple of questions into one here, which I have moderate luck actually doing. If you were to attach horizontal panels straight to the stud without a substrate, would oil canning be a problem? That's kind of part one. And the part two of that is, do you always need a substrate?
Oil canning, yeah, would be a bit of a problem for that application. I mean, depending on how your studs are ran and whether they're in plane, there'd be a lot of factors that played into that. But yeah, you would run into some trouble with that. And then a substrate would be required. Yes. Something to fasten those panels to.
This person is asking because all of your details showed a substrate. Do you always need a substrate for panels?
Yes, the answer to that question is yes.
Okay, great, thanks. And I've got a question about fire rating. All of a sudden I just lost the question. All right, does a metal, single skin metal panel add any fire rating to the fire rating that the substrate would have? So if it's a 1 hour fire rating, does the metal panel add anything to that?
Yes, the answer to that question is yes. And more information is available on our website, but I know that you can get Class A fire ratings out of some of our wall systems.
Okay, great, thanks. And then this is a person asking about attaching the panel clips. I think a couple of the details show the panel clips just kind of going into the substrate, but they need to be fastened straight into the metal structural framing, right?
Correct. I mean, depending on what the substrate is. So if the substrate is 5/8 plywood or OSB, 5/8 or better, then you can install the clips directly into just the plywood or OSB. But if it's less than, then yes, you would need to have a structural member behind those clips.
All right, thanks. Another attendee is asking about using panels in a diagonal application, whether that's possible, and we see a lot of that actually in projects coming to us. Are there any special detailings in that?
No, you would rely on, the same details and the same general, standard practices. I would have some suggestions for that as, as far as substrate is concerned. It would probably be best if you're doing a diagonal to do some kind of a solid substrate like 5/8 OSB or CDX. As opposed to trying to get those on a diagonal straight to some studs or some kind of member. It would be a little bit tough to pull off, but yeah, it absolutely can be done.
And I'm going to go back kind of a little bit and ask a question about electrolysis, galvanic corrosion that might occur between aluminum and steel. Is that something that people specifying need to be aware of?
Yeah, absolutely. Dissimilar metals is a huge part of the process as far as, some of the things to look out for. But yeah, any kind of dissimilar metals or galvanic corrosion, anything that promotes that, it's always a pretty big red flag as far as we're concerned. Once we go to projects, exposed copper on steel painted roof systems is a big one. Aluminum and steel is also not as bad as copper and steel, but yeah, it's definitely something to consider.
All right, we're a little bit over, but I do want to take one more question here, and that's the question of the through penetration examples that you showed appear to allow for external elements to be attached to the panel. In that circumstance, is blocking required behind the panel?
Yeah, I mean, depending on what it is that you're attaching, but yeah, if there's nothing, the answer to that question is yes.
Okay. Tyler, thanks very much for a great presentation. I really appreciate it. I hope everybody found this beneficial. We didn't get to everybody's questions. Some of them were pretty technical, and I'm going to encourage you to follow up. You'll have an email that you can follow up with technical questions tomorrow in that email tomorrow. If you want more information, you can go to aepspan.com. And again, the CEUs and certificates are going to be handled automatically, so you don't need to do anything. Just please allow us 7 business days for the processing. But thank you, Tyler, and thank you everybody for taking some time out and joining us today. We're going to do another webinar on June 23rd. It's on strategies for success with aluminum zinc coated roofs, and it's brought to you by Steelscape. And all of these events are listed on our website, metalarchitecture.com. Tyler, thanks again for sharing your knowledge and experience, and have a great day, everybody.
Yes, sir. Thanks, Paul.